What if an AI didn't just give you an answer, but knew when its answer was wrong, and then it actually tried again until it got it right? Well, that's exactly what we're breaking down today. We're going to move way beyond your simple chatbots and look at a self-correcting AI architecture. It's a multi-agent system that works like a team, built with AWS Bedrock and orchestrated by a really cool tool called LangGraph.
So why is this such a big deal? Well, the standard way of doing things, the single-agent approach you see on the left, it's kind of like having one employee try to do everything. It's fragile. You give it a complex question and it often just fails. The architecture on the right, though, it completely flips that script. Instead of one generalist, you get a whole team of specialists. This thing is designed from the ground up to be resilient and, most importantly, to correct itself.
Here's our game plan. We'll start by looking beyond simple bots. Then we'll meet the AI specialist team. After that, we'll dive into the self-correcting logic loop that makes this whole thing tick, put the system under pressure with some real tests, and then wrap up by talking about the bigger picture, the shift toward truly autonomous AI.
All right, let's meet the team. The whole idea here is simple, but it's incredibly powerful. Instead of one giant know-it-all AI, you assemble a team of specialists. Each AI model has one job that it absolutely excels at. Think of it as the difference between a Swiss Army knife and a surgeon's toolkit. Each tool is perfect for its specific task.
Every great team needs a library, right? And for this AI, that's its knowledge library. It uses Amazon Titan to read all of the documents and convert them into these numerical vectors called embeddings. Then it stores them all in a Chroma vector database. You can basically think of this as the system's perfect, searchable, long-term memory. Next up, we've got the quality grader. Think of this one as the team's super meticulous fact checker. Its only job is to look at a document the system found and give a simple yes or no. Is this actually relevant to the question? This step is absolutely crucial. It's the quality control that stops the AI from making up answers based on bad information.
Okay, so what happens when the quality grader says no to everything? Well, that's when the creative rewriter steps in. This is a much more powerful model, Amazon's Nova Pro. Its job is to be the team's brainstormer. It looks at the user's original failed question and tries to figure out what did they really mean, and then rewrites the question to be better for the next search.
And finally, we have the final answer writer. This role is played by Amazon Titan Lite, a really lightweight and efficient model. Once the team has found and approved all the right documents, this agent's job is just to be the communicator. It synthesizes all that complex info into a single, polished, easy-to-read answer for the user.
So we have our team of specialists, but who's the project manager? Who's calling the plays? That's LangGraph. It acts as the orchestrator, defining the workflow and telling each agent when it's their turn to act. But this isn't just a simple assembly line. LangGraph creates this intelligent, self-correcting loop.
This slide here lays out that workflow perfectly. It starts at retrieve, searching for documents. Then it moves to grade to check if they're any good. But here's the critical part, that decide node. If the documents are relevant, the path is simple. It goes straight to generate. But if they're bad, the workflow is smart enough to route over to transform, rewriting the query and sending it right back to the start. It's a built-in cycle of improvement.
Now, a really key detail for making this reliable is that the self-correction doesn't go on forever. The system has a hard-coded limit. It will only try to rewrite the query 3 times max. This is so important because it prevents the AI from getting stuck in some endless loop. It ensures it can handle errors gracefully, even if it ultimately can't find the perfect answer.
Theory is great and all, but let's actually put this system to the test. We're going to look at 2 scenarios, a really straightforward question to see the happy path, and then a tough, kind of ambiguous query that's designed to make the system fail, just to see if it can recover.
First up, the easy one. This is the ideal situation, right? A simple question where everything should just work perfectly on the first try. Let's see that happy path in action.
The user asks a very specific question. What is short-term memory? Now, the knowledge base has articles on AI agents, and those include discussions of memory types, so this should be a pretty direct hit.
And yep, it works exactly as you'd expect. The system retrieves a few documents, the quality grader quickly looks them over and gives them a big yes for relevance. With good documents in hand, the decision is easy. Move straight to generating the final correct answer. No loops, no rewrites, just pure efficiency.
Okay, now for the real test. Let's give this system something tougher. A more ambiguous question that doesn't really have a perfect match in the documents. This is exactly where a single agent system would probably just give up. So the user asks, what is deep learning?
And while that's related to AI, the source documents are specifically about AI agents, not some general overview of deep learning. So the initial search is probably going to find stuff that's only vaguely related.
And just as we predicted, it hits a wall. The system finds 4 documents that kind of seem related, but that quality grader acts like a really strict filter. It examines each one and concludes, nope, none of these are a direct hit. Every single document gets rejected. A simpler system would just quit right here.
And this is the magic moment. The system's own log shows its thought process. It doesn't just fail, it recognizes the failure and makes a new decision. All documents are not relevant. Transform query. The self-correction loop has officially kicked in.
This slide shows that whole correction loop playing out. Look at attempt 1. The creative rewriter tries a simple rewrite. It fails. Attempt 2. It tries a different angle, a comparison. That also fails. But it's learning from these failures. On attempt 3, it crafts a much more sophisticated query. And that's the one that finally works.
So, what does this all add up to? Well, this kind of architecture is a really significant step forward. It's not just about building a smarter search box, it represents a fundamental shift toward more autonomous and resilient AI systems.
This slide breaks down those core benefits really well. The multi-agent design gives you specialization. The self-correcting loop gives you reliability. And the underlying logic, which basically functions like a state machine, is what makes the system truly autonomous. The AI itself is deciding the best path forward at every single step.
So, to wrap this all up, here are the key things to take away. Multi-agent systems, like the one we've just looked at, are a powerful answer to how fragile single-agent systems can be. By creating a team of specialized models and using a tool like LangGraph to orchestrate them, you can build in self-correction. And the result is a way more reliable and resilient AI that can actually reason about its own failures and try again. And this all leaves us with a pretty fascinating question to think about. With architectures like this that can problem-solve, self-correct, and collaborate internally, are we moving past the era of just building AI tools and into an era where we're building true AI teammates?